Hello everyone, I am Jing Weidong, a third-year doctoral student in Professor Okuda Sensei's Environmental Chemical Chemistry Lab, and my research topic is QueCHERS and HPLC detecting method for PAH analysis in cyclone collected powder samples. Polycyclide aromatic hydrocarbons, PAH, is a kind of compound that's characterized by the presence of fused aromatic rings, and PAH are produced mainly as byproducts such as in the incomplete combustion process, such as coal and wood burning for heating and cooking, the fossil and biomass fuel burning, the industrial process, and the road transport. The PM-bound PAH can into the human lab via the respiratory tract and the skin to react with the cell and operating synthesis to induce the inflammatory and the DNA damage, so they are carcinogenic. So in general, the PAH or the particle samples are collected by the filter with high volume air samples, and we cut the filters into pieces into tubes, and the organic solvent and through the succinylate the ultrasonic or PLE extracting method to extract the pollutants for analysis. But now we use the cyclone to collect powder samples directly, and so we can put the samples into tubes and for extracting directly. Here is our lab succinylate extracting system. We put the powder form filter into this simple filter and add the organic extraction solvent at here, and turning on the heating element, so the succinylate will evaporate and here, and the condenser and here, and flushing the sample once and once again, so to extract the pollutants that are absorbed in the powder form filter. So after the succinylate extraction and the concentrating, we will get the samples for analysis. So we put these samples into this auto-injector box, put it in here and turn it off. And this is our HPLC detecting system. We use molecule water and ACM as mobile feed, and here are two pumps. They pump the mobile feed and the sample into the column. The column is sitting up and here. And after the column separating, the pollutants are flowed into the UV detector. So we use UV detector to analyze its pollutant characteristics. Then we will, through the UV detector, we will get samples per metric gram at here. So compare the samples per metric gram with standard solution per metric gram. We will calculate the concentration of each pollutant for next step analysis. The reason that I chose Okuda Sensei's lab, I thought it's mainly because it's opening and free research environment. Okuda Sensei encourage everyone to find the research points they are interested in, and give our full support. I think the interesting and security are the most important things for our research activity. I love it. Okay, because of the influence of COVID-19, so I just came to the lab 3 months ago. But I love this lab. I love this. Everyone enjoys their research and they do what they are interested in, and they are friendly and help me a lot for my research. I like this. When I'm in China, what I can do is just research starting and prepare for my research plan. And at least I joined one professor's lab who had the cooperating with Okuda Sensei in Xi'an University. I did some pre-experiment at his lab and to prepare for my research at here. So for my future goals, At first, I plan to graduate successfully, and after that, I plan to continue to some research work to use what I had learned here and what I had researched to improve China's atmosphere pollution.